Okay, can you hear me?
Yeah.
Okay, fantastic. So let's say that we can start now. So hello everyone, and I hope you're well. First of all, I would like to quickly remind everyone of the rules we need to follow. So microphones and cameras of all spectators will be kept turned off during the event. We will only allow speakers to keep their cameras and microphones turned on. So welcome to today's online event. My name is James Rossi and I'll be hosting today's event. I would also like to give you a brief description of what Tech Italia is. For those who do not know, Tech Italia is a community which was created in 2016 as a local meetup to give an opportunity and help IT professionals create networks and spread knowledge. We then started organising virtual and hybrid events in 2019, which allowed us to bring in knowledge from all over the world, as you can see today. There are currently more than 1,450 members, and we organise 2 events a month on average, addressing project management topics, development, marketing, design, and more on. So today's event is dedicated to women. Women are a big part of Tech Italia, as we always have at least one female speaker for every event. And they're also a big part of Sintra consulting, as there are many females working for the agency in the marketing area, communication, project management, design development, and more on. So this event has been organised with the aim of raising awareness about the role of women in tech, as we believe women don't represent the technical community enough, since most of them are sometimes discouraged to follow a technical career. So what we wanted to do at this event and many future ones is organise a meetup to which only women can take part as speakers. We believe this would partially represent a cultural change and add value to all the work that women do in the tech industry every day. So yeah, the first speaker of the event is Chiara Bernardini. Chiara is a developer and she's been working for Sintra for a few years now. So Chiara, can you hear me?
Yeah, I can hear you.
Okay, stage is yours. So start whenever you want.
Okay, I will.
I'll mute myself and I'll turn my camera off.
Okay. Can you hear my desktop?
Yeah, I can see your desktop. I can see your screen and can hear you.
Okay, my screen. Yeah.
Fantastic.
Okay, so I can start.
Yes, sure.
Okay. Hello, everyone. Thank you, James, for introducing me. I'm Chiara. I'm 27 years old. I have been working as a web developer for Sintra Consulting since 2018. I work with .NET and C#, and in my spare time, I love playing soccer and tennis, and I'm a TV series addicted. Well, but let's talk about Docker. Let's begin to say that when you need to build an application, to make that application available to the public, you need some place to host it. In the past, you would need to build your own computer and set up a dedicated web service called server, which is basically a computer dedicated to hosting websites and web services. But over time, this made the software painfully difficult to move around and to update. So the virtual machines arrived. A virtual machine is a virtualization of a physical server. That it means that the hardware resources can be divided into many parts. And this makes it possible to run what appears to be many separate computers on hardware that is actually one computer. But as you can imagine, all this can get very expensive in terms of hardware resources and hosting and time to install and configure the machine. And also IV operating system usage. For example, imagine if you have to install WordPress in local and you have to do lots of steps before you have it. So this is the reason why nowadays it's better to use containers. Containers can be considered as a sort of evolution of the virtual machine that introduces important innovation to the traditional technique. The concept is a little bit different because instead of hosting each operating system for each application, some common resources can be shared. In fact, containers share the same operating system kernel and isolate application processes from the rest of the infrastructure. This system optimizes resource usages and reduces the need for redundant operating system, as you can imagine, and which is the opposite of the virtual machine. As you can see from the picture, the hypervisors, which was the main component of the virtual machine, has been replaced by a new one, which is a container engine or Docker engine, whatever, that allows a developer to package up an application with all the components it needs, such as library and other dependencies, and ship it all out as one package. But what is Docker? Docker is an open platform for developing, shipping, and running applications by using containers. Docker is a client-server architecture, uses a client-server architecture, and the main components are three. The Docker, which is the client that sends comments and requests to the server. Dockered, which is the server that manages containers and images. And at the end, registry. There's a public registry where you can find all the open images, and which is called Dockerhub. If you look at this picture, you can see the client sending requests typed by the user from the command line to the server. The Docker comments use the Docker API, and the Docker daemon listens for Docker API requests and manages Docker objects such as images, containers, volumes, and networks. And then the server can find what it needs on the registry. Then, as you can imagine, there are lots of advantages of using Docker or containers in general. And here I listed some of them. First of all, containers are exceptionally light because they are only megabytes in size and took just seconds to start. Then you have a simplified deployment because the deployment unit is a self-consistent and version image ready to be run. Then scalability. A container running on a Docker instance can be easily replicated on another one with the same functionality. Isolation, because dependencies or settings within a container will not affect any installations or configuration on your computer or on any other containers that may be running. And at the end, security, because the applications running on containers are completely isolated from the others. So no container can see the running processes inside another container, and it can't interfere with its operation. But now I will tell you where you should use it. First of all, if you have to deal with a microservice architecture, containers are the best host for it. But what are microservices? Microservices is an architectural style that structures an application as a collection of services, because the software systems are generally burned as monolithic, like a single-tied software applications in which the user interface and the data access code are combined together into a single program. But as the application grows, monoliths can become difficult to maintain and deploy. So instead, microservices break down system into simpler functions. which can be implemented in an independent way. And this is the reason why containers are the best host for microservices, because they are autonomous and easily implemented, and at the end, efficient. If you have developers working with different setups, Docker provides a convenient way to have local development environments that closely match to the production one. And when you need to put your app on multiple phases of development, like dev, test, and production, it's a good choice to use it. But there's a huge but. All the glitters is not gold, because as the title says, you can face some potential pitfalls when using Docker. First of all, when you have to manage data, because if you want to preserve your data, you have to make sure not to write them inside the containers, because if you remove or restart your container, you will lose your data. So there's two solutions to this problem, volumes or bind mounts. The first one requires you to store your data in a specific part of the host file system, which is the Docker volumes directory, which is managed by Docker. While the other one requires you to store them anywhere on the file system of the host machine. I mean, the difference between them is the place where you have to store them. Then you have to know how to properly write a Dockerfile or a DockerCompose file. So no one tells you how to do it. So you have to do some web researches and hope to find what you need. Then you have to have a good knowledge of Linux shell. I mean, Linux in general, but in a specific way about the shell, because if you want to use Docker, you have to interact with it from the command line. So you have to know how to use it. And then you don't have an UI, a graphical interface. You can only communicate with console, which is not intuitive at all. And at the end, debugging, because debugging is very complicated and slow. So it's a waste of time during development. Well, some of these pitfalls can be solved in context, like the debugging point. I mean, it depends on what you are developing and where you are developing. So while the others, like how to write Dockerfile or a DockerCompose file, are recurring problems. In fact, this is the reason why now we have to roll up our sleeve. Well, the secret is to understand how to build an image and how to, or more images, and how to orchestrate them. Well, before it, we have to define some important terms. Well, a Dockerfile is a text file that defines a Docker image with a simple and cohesive syntax. A Docker image is a read-only template with instruction for creating a Docker container, which is an instance of a Docker image. Each instruction of the Docker file creates a new layer on the image, and when you change the Docker file and rebuild the image, only those layers which have changed are rebuilt. So in short, you have to write a Docker file for building an image that runs containers. Here we have a Dockerfile example, a short example with some instruction. The first one is from, which is the most important one, and that cannot be missed out. It initializes a new build and sets the base image from where to start. Then work there, that creates a working up directory for other instructions like run, copy, and add, which follow it in the Dockerfile. Then copy it installs app dependencies, run. This is one of the most important instruction. It generates a new layer that brings with it the changes derived from the comment itself. So it's recommended to insert multiple related comments within a single run instruction. In this case, we have npm as a comment and install as a parameter that is installed in application and all the required packages for the proper functioning. Expose, it lets Docker know which ports the container will listen on during runtime. And at the end, cmd, that it takes effect in the container and it doesn't modify the image nor add new layers. This instruction sets the comment to be executed when running the image, and you can only add one of these inside the Dockerfile. But now, what should I do with these images? Well, now if you need to run Docker applications that require both backend and frontend, you have to use something for defining and running multi-container applications. That is DockerCompose in this case. In other words, it is an orchestrating tool for complex applications with minimal functionalities. And if you want to use it, you have, first of all, define the app environment with a Dockerfile, so it can be reproduced anywhere. Then probably write a DockerCompose YAML file. And at the end, execute a special command, which is dockercompose up. Here, if we take the WordPress problem that I told at the beginning as an example, we can easily fix it with DockerCompose, because here we have a file, the file. We have all the services you need for making WordPress working. We have the data management section with database and volumes. You can see the volumes, the solution I told before, and the environment variables. Then here we have the WordPress section with all its environment variables. And at the end, you have to run DockerCompose up. So it's very easy. But what to take home? Well, as you can understand, virtualization is not enough. Now containers are the standard, so then Dockerfile and DockerCompose are okay, but for simple scenarios, for simple situation, and for everything else, there's the cloud that like Kubernetes, Azure Contain Instance, or OpenWhisk. So we have a ride at the end. I hope you didn't get bored, and thank you for listening.
I'm sure no one got bored because it was very interesting. So thank you for that. There's a question in the chat. Francesco was asking, what can I do if I want to use cloud tools?
Okay, well, as I told before in my speech, a container is, well, independent of the development scope. So, and it is decoupled from the host operating system. So it can run on anything from a laptop or to your cloud of choice. In fact, one of the main advantages of the developing application with containers is that if you want to move it on the cloud, it's not a big deal. I mean, it's like moving your application from an environment to another, for example, from test to production. And of course, it's not magic. You have to do something. You have to convert your YAML Docker Compose files into appropriate files if you want to use Kubernetes, you have to convert them into Kubernetes YAML file. And because the syntax is a little bit different. And at the end, you have to move all on cloud, and that's all. The game is done.
Okay, thanks for that, Chiara. I'm sure you've answered that.
Okay, thank you for listening.
Well, thank you for sharing your expertise and your knowledge. It was very interesting.
Thank you.
So thanks for that. And if you have any other questions for Chiara, you will receive her contact details in the same email as the presentations. So if you want to get in touch with her privately, feel free to do so. Thanks again, Chiara. That was interesting. And okay, so the next speaker is Laura. Laura is a web developer at Shopify. Laura, can you hear me?
Yep.
Hello, Laura. How are you?
I can start probably, right?
Yeah, sure.
Okay, let me share it.